We turn now to that remarkable scientific breakthrough. 13,000 years after the last dire wolf walked the Earth, scientists say they've now brought them back.
The dire wolf, extinct for 10,000 years, a ghost of the Ice Age. Most people believe nature's mistakes are irreversible, that once a species is gone, it's gone forever. But what if we could bring back not just a creature, but a missing piece of the Earth's very soul?
The dire wolf is the first de-extinct species.
A team of scientists in Dallas, Texas, just used genetic code from a 72,000-year-old bone to do the impossible. The stakes are immense, not just the success of the science, but the very future of conservation. They successfully created 3 pups, Romulus, Remus, and Khaleesi. But as these ancient predators grow, the question isn't whether they survive, but what their arrival will unleash on a modern world utterly unprepared for them. The hero of our story isn't a single person, but a team driven by a single purpose: to reverse ecological debt. Humanity's actions are driving 30% of global genetic diversity toward extinction. The dire wolf, a magnificent keystone predator essential to ecosystem health, is the perfect, noble victim, reduced to a whisper in time. It became abundantly clear that we need new tools and technologies for conservation. We thought this was a really cool way that we could create value, create impact, and thoughtfully rewild some of these species. But this vision carried an immense personal and professional cost. Hundreds of millions of dollars, years of research, and the high risk of global condemnation if they failed. The pressure was immense. The rescue wasn't from a cage, but from the chasm of time. The crisis point: extracting and engineering the ancient DNA. The team extracted fragments from a 13,000-year-old bone and a 72,000-year-old inner ear bone. They were operating with fragments of a ghost.
We were able to generate 2 genomes, 2 direwolf genome sequences from that, which we then compared to all the other wolves for which there's already been data generated. And when we do that, we want to figure out where it is that these 2 dire wolves are similar to each other, but different from the other wolves that are out there. And so we come up with this list of genes where they're distinct.
Every gene edit was a razor-thin chance. They made just 20 modifications across 14 genes, tweaks that dictated the dire wolf's large size, white coat, and characteristic vocalization. One error, one misplaced segment in the 72,000-year-old code, and the process would collapse. The entire team held their breath when they inserted the re-engineered DNA into the denucleated egg cells of a surrogate dog, Romulus, Remus, and Khaleesi, born on October 1st, 2024. The animals were recovered, but the outcome was dangerously uncertain. They were on track to grow up to 6 feet long and 150 pounds. Was this truly the dire wolf, or a genetic mistake? When you're playing with nature, nature usually wins. Genes do many things. We may create animals that have lots of medical problems, or even a super rat that kills all the other animals around. This is hubris, not conservation. For months, every measurement of the pups was done with trepidation. Were their vocalizations correct? Was their massive size a sign of health or an unforeseen defect? Every time they let out a strange, low growl, the team couldn't help but ask, have we created the problem we were trying to solve? The greatest fear was an unintended consequence, an ecological time bomb. The day of the climax, the transfer to the 2,000-acre protected preserve, the high-security gates, the unknown territory, the fear of the final, irreversible action. The camera is positioned for the grand reveal, the sight the world has waited for. The pups emerge, massive for their age, with characteristic white coats. They sniff the ancient earth for the very first time. The sound was immense, primal. For a split second, the team was stunned, remembering the warnings of an ancient monster returning. But then, they looked closer. This wasn't a terrifying signal of nature's wrath. It was a call of belonging. It was the sound of a species thanking its makers for the second chance, proving they were not a threat, but a gift. The unexpected event, the howl, the defining characteristic, was one of pure, unadulterated life. Romulus, Remus, and Khaleesi will live out their lives protected, loved, and monitored. They are the living legacy, the proof of concept. The greatest impact of the direwolf project wasn't in the past, but in the present. Using the techniques learned, Colossal was able to clone 4 critically endangered red wolves, injecting fresh, needed DNA into a struggling gene pool. A small but important step in fortifying that species.
Yes, it would be really amazing to see a mammoth, but the tools that we're developing on the path to these species have immediate application to species that are not yet extinct.
The ethicists were right. Nature is complicated, but the team at Colossal proved that our big brains can be used to reverse some of the bad things we've done to the world. By saving the ghost of the dire wolf, they developed the tools needed to save species like the red wolf that are still with us today. The dire wolf was supposed to be a monster, but it taught us that the greatest hope for the future doesn't come from discovering new life, but from giving a second chance to the life we thought we had lost.